Thank you. So good morning, ladies and gentlemen. My name is Jan Kočí. I'm from Technical University of Liberec and from the Institute of Nanomaterials. But our presentation is not intended purely into AI, but I think it's overlapping because at our institute we need to use machine learning, AI techniques for analyzing the data. But the prerequisite for doing that is also to automatize and to work and collect the data automatically. And there are a few things which must be done in order to be purely data-driven, to be able to work with the data, and also to change the mindset of our researchers to work with the data in a proper way in order to be able to work with them afterwards. So our approach, how to do it, and what we want to do at our institute or university will be into the Věnceslav. So Věnceslav, could you tell about our project approach of the DDR?
So hello, good morning. As was said, my name is Věnceslav Chumchal, and today I will introduce you to our approach to data-driven research. So I will start with our motivation from the perspective of an AI department. Then I will proceed with the preview of our proposed data collection solution. Then describe a workflow of instrument operator in our web application, and then we will see what it can bring to you. So, why does AI department care about data-driven solutions? The answer starts with something that everybody talks about, but nobody has ever seen. I will explain why. By big data, we usually mean quantity of data that is unprocessable by one PC, even powerful one, or I need distributed computing systems, right? But we also could see it as amount uncollected by one team or multiple teams. So it means if there are teams to collect and process, individual cannot do it all the time, so probably he or she doesn't see. Of course, there are scientific and business goals achievable only with big data. A well-known example is GitHub Copilot. If you don't know, it's AI system for generating code. It has its drawbacks, but it's a useful tool, and at least now we know that Microsoft has involved, not because he will source Windows, but because he wants to monetize this amount of data that's available. And of course, from this implies that we need agreed upon structure and machine readability to process the amount of data in that is usable. But infrastructure first. If you are the team for which is essential to have great data infrastructure, because only purpose is to work with data and gain insights from data, you have high demands or requirements. One of those requirements are easy accessibility. It means you can access data in few clicks. Scalability, you are not limited in amount or capacity or throughput. It's reliable. There's nothing that it just shut down and you have to wait day to boot it up. It's safe in the sense that the last disk where your data was stored doesn't suddenly crash and data is lost. And it's secure in the sense it's protected from the attackers who want to steal or log your data. And so this implies you need first data engineers as people who will build this infrastructure, and then people who will use and gain insights from the data could come. So now I will describe our solution, what we propose. From the perspective of the entities, it's simple. We have users who take measurements on the instruments and gather it to data sets. From the perspective of the software components, we have a web application for management of these entities. We have object storage provided by SESnet, and we have Apache Flow for data workflows and data management. So our web application has 3 main features. Ones, we want a list of instruments, datasets, and relevant metadata. We want to interface for data and for instruments, and also we want to generate instrument logs for administrative purposes like billings. So here I have added this database scheme, so you can see it's built of these 4 entities. On the right is resources entity, which is for integration with the internal grant and project system, and for the proper generation of instrument logs. So another part of the solution is S3 storage. Free storage is chosen by us because we can save the type, volume, count of data. In the pilot run, we were provided with 10 terabytes, so it means thousands of millions of files to save there. Of course, one of the other important feature is we are able to search and filter data by our custom metadata. The infrastructure, or S3, is part of the national research infrastructure. So the data is saved in the Czech Republic, as it's maybe important. And it's free with an asterisk, because if you are academic institution and member of SESnet or infrastructure and you don't have high requirements for capacity, it's just part of the membership fee. So few things about S3. S3 is object storage. It means there are no folders, only buckets and objects. So the only way how to distinguish between files or the objects are in buckets, and which is, as you can see in example. And the object name, even if it looks like there is some folder structure, it's just prefix, and there is no way how to save any metadata to the prefix. All of the metadata should be saved with the object itself. The benefits of object storage or this approach is you can have high scalability and high data throughput. So, and last one, a main feature, main component is Apache Airflow. We have chosen it not just because we want to transfer data, but we want some way how to manage the PC disk and S3, because it's responsible for automated creation of structure and other stuff. And mainly, It's the tool for scheduling, monitoring, and executing ETL pipelines, which means ETL means extract, transform, load. In the language of our main use case, we extract the data from instrument PC. We enrich it with metadata from the web application database and load it to the S3. So on this screenshot, you can see the interface of Apache Airflow. Data workflows are called DAGs because it describes what it is in its essence, directed acyclic graphs. And there are examples of workflows given by Airflow developers. And on this slide, you can see visualization of the DAG after you load it to the system. So it's essentially just nodes and some conditions or branches from the extract, like the start and to the end, the load to other system. And here you can see a network, diagram of network of our solution. On the right is private network for instruments with Apache Airflow, because it's easier as Airflow needs direct access to PCs, and there is then only one point where data flows from the network. In the middle is our web application. In the future, we plan integration with laboratory, notebook, and with some tools for data management plans. On the left is CESNet infrastructure with S3 and Apache Hadoop and distributed computing system for big data we plan to use in future, as we will find some proper use case and have data in S3. So I will follow with description of our web application. It's just in check as it's just pilot run and some simple demonstration of the workflow of the operator. So the first, you have to, after the login, you have to choose your department, your role, and be approved from the administrator. After that, you can proceed to registration of the measurement instrument. We have tried to come up with all the relevant information and metadata we would need for the proper connection of the instrument to the network, and to already collect all metadata that is usable in for enriching the measurements information. So here are just other slides of the form. And the registration and connection of the instrument, you can add your data set, nothing complicated. In our implementation, you have to connect the financial resource from our internal system, as there are a lot of metadata already given by users. And finally, you can start the measurement as a digital form of the process, physical process you will do. And so the Airflow could notice and start with listening on the given disk or socket, and wait for the newly created data to in automized way collect it and enrich with the metadata from our systems. And this is just an example of lists, how every entities could be accessed. So what it can bring to you. Of course, Industry 4.0 isn't just about IoT and real-time systems. There are companies that do material research, do measurements, and we think that this is this is simpler than some system with MQQ2 broker and associated infrastructure, but it's still enough and with decent capabilities if we are talking about Apache Airflow. Of course, it's also beneficial for our partners who work on contracts with us, as if the collaboration internal between multiple departments in our institution is needed, it's easier for us. And of course, we can take this solution, even generalize or tailored to your needs and help to build you similar.